Welcome to 5G Hub. Today we will talk about 5G new radio bandwidth. 5G new radio operating bandwidths will have two different frequency range 1 and frequency range 2. The 5G new radio has been developed to operate in these two different frequency regions. Sub-6 GHz is referred to frequency range 1 and sub-mm wave referred as frequency range 2 in the 3GPP radio specs. In each band, the new radio may operate in either FDD or TDD duplex mode. Also, a band may be supplementary downlink and supplementary uplink, used to provide additional capacity in the respective direction. Given the wide range of frequency which 5G new radio is required to support, three subcarrier spacing 15 and 30 and 60 kilohertz are identified for operating at frequency range 1, and for sub-6 and for wave 60 and 120 kilohertz are designed for operating in frequency range 2 for wave bands. For uplink channel bandwidths, from a base station perspective, the G-Node B channel bandwidth supports a single new radio RF carrier in the uplink or downlink. So different user equipment channel bandwidths may be supported within the same spectrum for transmitting to and receiving from user equipments connected to the G-Node B. The assignment of the user equipment channel bandwidth is flexible and within the G-Node B channel bandwidth. The new radio base station is able to transmit to or receive from one or more user equipment bandwidth pairs that are smaller than or equal to the number of carrier resource blocks on one RF. So in this figure, you can see this is the total channel bandwidth in megahertz, and the transmission bandwidth configuration will be number of resource blocks, and the active resource blocks is the actual transmission bandwidth or resource user equipment bandwidth part. So the number of the physical resource block configured in any channel bandwidth ensures that the required minimum guard band at the left-hand side of the transmission bandwidth configuration is granted between neighbor channels to be make isolation between the different channel bandwidths. So here for the channel bandwidth for each new radio frequency range FR1, we have a different numbering from N1 up to N90, and each one of them have the supported channel space carrying. For example, N1 will support 15, 30, 16, N2 like N1, and for example, N78 or 3.5 gigahertz will support it also 15, 30, and 60. Okay, this is a frequency range 1. What is the maximum channel bandwidth for this band will be 100 megahertz, and there are different frequency ranges to support this channel bandwidth like N77, N78, N19, N48, and so on. What about channel bandwidth for frequency range 2 or wave band? We have a different band like N257, N258, and N260, and the maximum channel bandwidth will be 400. 400, and duplex mode will be always TDD for time division duplex. Okay, now the question is, what is the maximum transmission bandwidth and how we can calculate number of resource block versus each band? For example, here the maximum at bare 3 GBP, the maximum transmission bandwidth will be specified in unit of resource blocks. So here in this table of 3 GBP, you will find the maximum transmission bound configuration of number of resource blocks. So the maximum will be related to number of resource blocks per each subcarrier channel spacing in kilohertz. So for example, for bandwidth 50 megahertz, the maximum number of resource block to be used in subcarrier spacing 15, for example, 207. And also for the minimum guard band specified, but here the unit will be kilohertz. For example, for 50 megahertz for subcarrier channel spacing 15, we will have 692.5 kilohertz minimum guard band. Okay, so the number of resource blocks configured in any channel bandwidth shall ensure that the minimum guard bands specified in this table be met. For example, for resource block calculation, if we have this is the equation of the relation between the channel bandwidth and guard band and number of subcarriers, we have a table for minimum guard band for each channel bandwidth and a table for maximum transmission bandwidth configuration for each channel bandwidth for frequency range 1. So to determine or calculate the number of resource block, we will have this equation: channel bandwidth minus double of guard band left hand side divided by one resource block. Based, this resource block will be based on the channel spacing carrier 15, 30, or 6. Here, for example, if we have subcarrier spacing 15 and the channel bandwidth 50, so we will have guard band 698.2.5 kilohertz, and for subcarrier spacing 15, actually we have one resource block 12 multiplied by 15, so you will have 180 kilohertz. So number of resource blocks here will be, as per this equation, 270 resource blocks. This is matched with the table of number of resource block. This is video was about the 5G new radio channel bandwidth, frequency range 1, frequency range 2, and what are the maximum and the minimum transmission bandwidths in each frequency range, and how we can calculate number of subcarrier per each frequency band. Okay, thank you, and look forward to see you in another video. Thank you.